Hello guys, welcome to the today's challenge from LeetCode, and today's challenge is first completely painted row or column. So we have to return the first completely painted row or column. And now let's go into the problem statement. In this, what it is given that we are given a you know zero indexed integer array ARR and an m cross n integer matrix mat. Okay, so we are given two things: zero indexed integer array ARR and an m cross n integer matrix mat. ARR and mat both contain all the integers in the range 1 to m into n. So it includes 1 and it includes 1 m into n, but it doesn't include 0. It includes 1 and it includes m into n. So what we have to do, we have to go through each index I in ARR starting from index 0. We have to go through each index I in ARR starting from index 0 and paint the cell in the matrix containing the integer ARRI. Return the smallest index I at which either a row or column will be completely painted in mat. So basically ARR contains the same values which the matrix has, and if we are able to associate with the values occurring in the matrix with their row and column value, so when we traverse this array, for each value what we will do, will correspondingly increment that frequency row and frequency column values. We'll be maintaining one frequency row and frequency column values, and as soon as that frequency row and frequency column value reaches its limit, so for a row, how many elements could be there? That could be equal to the number of columns. For a column, how many elements will be there? That will be equal to the number of rows. So if you are able to reach that value, then we can return that index. So having said that, let me concisely write what we are going to do. So we are going to do associate each value in the matrix with its row and column in a position array. Okay, and then traverse the array ARR array, and then for each value we increment the corresponding row array and corresponding column array, and whichever reaches the limit, we return the, or whenever the limit is reached, whenever the limit is reached, we return the index I. So with this, let's try to implement our approach. So first of all, we will take n is the ARR dot length. Remember, it contains all the values, so this length will be equal to so it has to contain all the values from 1 to m cross n. This is the length of the array. Okay, and then there is this row. So int rows is equal to mat dot length, calls is equal to mat of 0 dot length, and then what we will do, let's declare one positions array. So this will be positions. Okay, it will be taking all the values from, so see, it has to contain all the values from 1 to m cross n. Okay, and array will contain all the values till 1 cross n, but since it is starting from 1, so we'll have to take values from n plus 1. So if it is starting from 0, then n is sufficient, but since it is starting from 1 and it includes m cross n, so we'll have to have n plus 1 in positions, and then the second part will be a two-dimensional, a two-element array. Now what we will do, we will go through each matrix. So int I is equal to 0, I less than rows plus plus I, and then what we'll do for int j is equal to 0, j less than columns plus plus j, and then what we will do, we will take positions of ij. So first of all we will put a value in the val, and then positions of val will be equal to new int ij. Okay, like this we will do, and after doing this, what we'll do, we'll declare this frequency rows, and this will be equal to new int array. How many rows are there? So how many rows are there? The row count is in rows. Int array frequency calls is equal to new int calls, like this, and then for int I is equal to 0, I less than, for int I less than n, because now we are traversing the array, and here we'll be getting this array value. So array I will be the value, so this positions of array I will be the value, and the 0th thing will be the array. Okay, so it will be int r is equal to this, and int c is equal to positions arr I 1. Okay, and if frequency rows of r, so we'll increment this, is equal to the calls, then we'll return I, else if plus plus frequency calls of c is equal to rows, then we'll return I, like this. And then here what we will do, that we will be returning so if this is not, if anywhere we are not able to return, then we are not, we are left with only one choice, that we can return -1, but this condition should not happen, because the constraint of the problem guarantees that some values will be completed and all will be returning some index I. So let me just run this. Matrix of I j. Matrix is mat, not matrix. Perfect. Let me submit this. I hope you liked this solution. With this, I would like to thank you. Thanks one and all. Happy coding. Best wishes.